In this video, I will continue to go over the questions from the study guide. So Unit 7, Question 9. There are 8 students in Miss Burns' senior English class. The students are, and they are listed, the class is grouped by their ages. Find the set of 17-year-olds united, that's a union, 18-year-olds. So we want 17-year-olds or 18-year-olds, but we want them as a set, so we'll list all of them. So go down through here. Here is an 18-year-old, 17, 18, 17 and 18. We don't want the 16-year-olds, so we will just list them as a set. Jenny, Tommy, Richard, Harry, Steve, and Hunter. And of course there's only 6 listed because 2 of them were 16-year-olds and there were 8 students total. So those are the set, or that is the set of 17-year-olds united, so a union with the 18-year-olds. If we wanted to find the set of 17-year-olds and 18-year-olds, so the intersection of them both, that's actually an empty set. That is an empty set because you cannot be 17 and 18 at the same time. Let's look at question number 10. In a bag of marbles, there are 7 yellow, 4 red, 3 blue, and 2 black marbles. So let's first find the total. 7 plus 4 plus 3 plus 2. So 7 and 3 make 10, 4 and 2 make 6. So we have 16 marbles. We want to find our probability of not blue. The little C means complement, so that means not blue. Well, there were 3 that were blue, so if we take those from the 16, that gives us 13 out of 16 that are not blue. In our calculator, we can change that to a decimal. So if you've already done alpha y equals and typed in the 13 over 16, you'll see it doesn't reduce. You can go math decimal, so math 2, to change it to a decimal, or you can just divide 13 by 16. Math decimal, or just divide the fraction. So that gives us a decimal 0.81, which is 81%. Question number 11. What is the probability of rolling an odd number on a 12-sided die and spinning a composite number on the spinner? So we want probability of odd and composite. When it's an and, we're going to multiply. So let's set up our fractions. Our odd numbers. So on a 12-sided die, the odd numbers 1, 3, 5, 7, 9, 11. It's half of the die. So 6 out of 12, or you could even just use 1/2. There's 6 odd numbers out of the total 12 on that die. On our spinner, when we talk about composite numbers, we either have prime or composite, and 1 is neither prime or composite. So 1 is neither. 2, 3, 5, 7, 11, those are our primes. Oh, we don't go up to 11. So 2, 3, 5, and 7 are our primes. So composites are 4, 6, and 8. They're composed of numbers more than 1 in itself. So we have 1, 2, 3 composite numbers out of the 8 sections. So we can multiply those fractions. 6 out of 12, 3 out of 8. We are multiplying because it says and. So our fraction is 3/16, and there's our decimal, 0.19. We would round. Once you have your decimal, remember you can go math fraction to change it to a fraction. So 3/16, and then the decimal 0.19, so that gives us 19%. The concession stand sales at a baseball game are in the table below. Find the following probabilities. So we have our data here. We want to know the probability that a randomly selected person is a child or had a hot dog. So child or, so that's a union, hot dog. Because this is an or, we're going to add our fractions. We multiply when it's an and we add when it's an or. So the chances of this occurring, so our children, look at all the children here. We have 46 out of the 105. And hot dogs, so people ordering hot dogs is 35 out of 105. But we need to subtract out those children that had hot dogs because we counted that group in both probabilities. So we need to subtract the intersection of children and hot dogs. So this is the probability of a child from this data, 46 out of 105. This is the probability of someone getting a hot dog, 35 out of 105. And we have to subtract their intersection, those children that also had hot dogs. So 46 plus 35 minus 21. We can just add and subtract the numerators because our denominators are all the same. So we get 60 out of 105. And that will reduce to 4/7. So as a decimal, we get 0.57, which is 57%. Let's look at the next probability. Find the probability that a person ate a hamburger given they were an adult. So we're only looking at the adults. So given that they were adult, these are the only numbers that we're able to look at. Find the probability that a person ate a hamburger given they were adult. So let's write our probability statement. So hamburger given that they were adult. So our total number of adults in this is 59. Of those adults, how many ate hamburgers? So in that adult section, you cannot look anywhere else in the table. We just want these 22. Because if you get any other numbers, you're considering the children. So if you use this 31, any other numbers in the table other than those adult numbers would not be the probability we want. We want what's the probability that a person ate a hamburger. There were 22 ate a hamburger given they were adults. So that was out of the 59 adults. So we have 22 out of 59. That actually does not reduce when you do math fraction. So changing it to a decimal, we get 0.37, which gives us 37%. Let's now look at the Unit 8 questions. We need to prove that each pair of triangles are similar. Given that ratio is proportional. So NO, that's this side here, to QO equals PO, that side, to MO. So that's a pretty good start given that, because sides need to be proportional in order to have similar triangles, and that's what we're trying to prove. So let's start with our statements and our reasons. So our first statement is just the given information, that NO, QO with PO, MO is proportional. And our reason is because it was given. So when we think about proving similar triangles, our options are angle, angle, side, angle, side, or side, side, side. So far I already have side, side. If I can get one more side or an angle, we can have a proof. Well, we definitely cannot do side, side, side because we don't know anything about this third side. But look inside of here, in order of the figure, side, angle, side, that's exactly what we have. We have vertical angles with these angles, NOM, NOM. The O has to be in the center because that's the angle we're naming. That is congruent to angle O, no, you cannot start at O, angle POQ. POQ, and that is because of vertical angles. So sides are proportional, angles are congruent. We have enough to say side, angle, side. So number 3, our triangle MNO is similar. MNO is similar to PQO. And we prove that by side, angle, side similarity. Let's look at the next proof. Given that the angle S is congruent to angle V, so angle S congruent to angle V, we need to prove that the triangles are similar. So again, start with our statement and reasoning. So our first statement is our given information. Angle S is congruent to angle V. That was given. So again, in order to prove similar triangles, we either need to prove with angle, angle, side, or side, side, side. So we're already on a good start for angle, angle because we have one pair of angles. And notice, once again, we have vertical angles. So let's name those. STX, STX, again the T has to be in the center to name that angle, is congruent to angle UTV. Now I know UTV does not exactly line up with STX as far as naming the triangles, but when you're talking about the angles, we're just saying T is congruent to T, and we do have to use the 3-letter naming because there's actually 4 angle T, so we need to specifically tell which angles we're referring to. That is true because of vertical angles again. But our proof this time is angle, angle. So triangle STX is similar to STX because we started with S in our triangle naming. We have to start with the V because they correspond. It does matter when you're naming the triangles. And that was angle, angle similarity. Number 15. To find the height of a dinosaur in a museum, Amar placed a mirror on the ground 40 feet from its base. Then he stepped back 44 feet so that he could see the top of the dinosaur in the mirror. Amar's eyes were approximately 5 feet 6 inches above the ground. What's the height of the dinosaur? So 5 feet 6 inches would be 5.5 feet, because there's 12 inches in a foot, so 6 inches would be half of that. So the diagram shows all of that information. We are now going to solve for the height of the dinosaur. So that is going to be represented by h. I like to start with the unknown. So h corresponds to the height of the man, so 5.5. Then we must come back to the dinosaur triangle. When you're talking about similar triangles, the corresponding pieces have to line up even in your work. So dinosaur to the man, we have to come back and get this number from the dinosaur figure, 40 to 4. That does matter when the corresponding pieces are in your proportion. If that's not done correctly, you would not solve for the height. We will cross multiply, so 4 times h and 5.5 times 40. So we get 220 for that. We'll divide both sides by 4, and h equals 55. And our units for this situation are in feet. Question 16. We have triangle LEG is similar to triangle ARM. We need to find the length of RM. So RM, I'm going to let that represent by X. Because these are similar triangles, we can set up a proportion to solve. So again, I like to start with the missing, so X, and then notice what X corresponds to. RM, you can look in the naming, RM corresponds to EG. Or you can just look in the figure, RM is opposite the angle that is marked. So the opposite side from the angle that's marked. However it works best for you to get the corresponding sides. But X does correspond to that 5. Then we need to come back to this triangle where we started and pick a number. It doesn't matter, you could use the 12 or the 6, but just pick a number, and then you need to find the corresponding number. So RA, again look at your naming, RA or AR, that's the same thing. It corresponds to LE, so this 16. Again, just visually you can see it's the measurement that comes off of the marking to the X, from the marking to the X. And the other number also does that, so you may want to use the letter naming if you're having trouble matching those up. So 12 corresponds to 16. Then we cross multiply to solve, so 16x equals 5 times 12 gives us 60. We'll divide both sides by 16, and we get 3.75. Question number 17. We're going to determine if each of the following dilations will result in an enlargement or a reduction. So if we went from our ordered pair XY to 9X, 9Y, that would be a K value of 9. So that K value is our scale factor, and so that tells us if it's an enlargement or a reduction. Well, this one will be an enlargement, and that is because this K value is greater than 1. We can't just say that it's a big number. It's because it's greater than 1 that causes it to enlarge the figure. So that means here, part B, that would be a reduction. And that is because K is between 0 and 1. So 0 is less than k and k is less than 1. So again, we can't just say that our k value is a small number, because just because it's a small number, 2 could be considered a small number, but that would actually result in an enlargement. So use the greater than 1 or less than 1. And of course we restrict it between 0 and 1, so we're not dealing with negatives. Watch the next video for the rest of the review explanation.